Hello, my dear students. Today we are going to continue our discussion on Chapter 1. We are going to discuss the electronic configuration of the elements of first transition series, and we are going to discuss their oxidation states, and we are going to discuss the general properties of the first transition series. So let us start. My dear students, today we are going to discuss the electronic configuration and the oxidation number of the first transition series. So, as shown on the screen, the element and its group and its electronic configuration. Scandium, that in group 3b, its electronic configuration, it takes the inert gas structure of argon ending by 4s2 3d1. Then titanium, group 4b, configuration argon 18, 4s2 3d2. Vanadium has atomic number 23, group 5b, and configuration end by argon 18, 4s2 3d3. Chromium has atomic number 24, group 6b, has configuration argon 18, 4s1 3d5. And manganese has atomic number 25, group 7b, has configuration argon 18, 4s2 3d5. And iron has atomic number 26, group 8, the electronic configuration end by argon 18, 4s2 3d6. And cobalt 27 in group 8 also has electronic configuration argon 18, 4s2 3d7. Nickel has atomic number 28 in group 8 also, has configuration argon 18, 4s2 3d8. And copper 29 in group 1b has configuration argon 18, 4s1 3d10. And zinc atomic number 30 in group 2b has electronic configuration argon 18, 4s2 3d10. If we talk about their oxidation number or oxidation states, and the most stable oxidation states for scandium has only one oxidation state, positive 3, so it is the most stable one. And titanium, positive 2, positive 3, positive 4, where the most stable oxidation state, positive 4. And vanadium, positive 2, positive 3, positive 4, positive 5, and the most stable oxidation state, positive 5. And the chromium, positive 2, positive 3, positive 6, and the most stable oxidation state, positive 3. And manganese has different oxidation states as shown, positive 2, positive 3, positive 4, positive 6, and positive 7, where the most stable oxidation state is positive 4. Iron, positive 2 and positive 3, and the most stable is positive 3 oxidation state. Cobalt has oxidation states positive 2, positive 3, positive 4, and the most stable one is positive 2. Nickel, positive 2, positive 3, positive 4, and the most stable is positive 2. Copper, positive 1, positive 2, and the most stable oxidation state, positive 2. And zinc has oxidation state only positive 2, and also it is the most stable oxidation state. So we are going to discuss some compounds of these elements: SC2O3, TiO2, Ti2O3, TiO, V2O5, VO2, V2O3, VO, chromium, CrO3, Cr2O3, CrO, manganese, MnO2, Mn2O3, MnO, and KMnO4, and Fe2O3, FeO, and cobalt, COCl3, COCl2, nickel, NiO2, Ni2O3, NiO, and copper, CuO, Cu2O, and zinc oxide, ZnO. As shown on the screen, there are different oxidation states for oxides for these elements and other compounds. So in this table, we have different give reasons. So the first one, which is shown on the screen, there is abnormal electronic configuration or anomalous electronic configuration for chromium and copper. The reason for that, because chromium, when it has the electronic configuration argon 18 for S1 3D5, the 4s and the 3D sublevels are half-filled, which have lower energy and extra stability. While in copper argon 18 for S1 3D10, the 3D sublevel is completely filled, which is more stable and less energy. My dear student, notice that the atom is more stable if the D sublevel has no electron, is empty, or half-filled D sublevel D5, or completely filled D sublevel D10. My dear student, when the transition element form ion in its compound, it loses electron first from the outer shell for S, then from 3D. So we have division in this point. Transition metals show several oxidation states. The reason for that, because their valence electrons in both 4s and 3D sublevels, that they are near to each other in energy, so lose the electrons from them successfully. My dear student, notice that metals from groups 1a, 2a, and 3a have only one oxidation states. Otherwise, losing more electron breaks completely fill the energy level, which require very high amount of energy. My dear students, we have give reason also in these points. All first transition series have oxidation state positive 2, except scandium has oxidation state positive 3 only. The reason for that, because scandium has electronic configuration argon 18 for S2 3D1. When it loses 2 electrons from the 4s sublevel and 1 electron from the 3D sublevel, it gets an empty D sublevel, which is more stable. Another give reason here, my dear students. This give reason arises from the oxidation state that increases from scandium to manganese positive 7, in which the maximum oxidation state agrees with the group number. Give reason here is for the question that the oxidation states decreases from manganese to zinc. The reason for that is due to the increase in the ionization energy as the increase in the positive nuclear charge. Another give reason in this point, the maximum oxidation number cannot exceed the group number. The reason for that is it loses all the electrons in the 4s and the 3d sublevels, which equal the group number, except elements of group 1b, that's copper, silver, gold, may have oxidation state positive 2. My dear students, we have another give reason in this point. Oxidation of iron positive 2 to iron positive 3 is easy, while that of manganese positive 2 to manganese positive 3 is difficult. The reason for that, iron that has atomic number 26 has electronic configuration argon 18 for S2 3d6. So iron positive 2, argon 18 for S0 and 3d6. That when oxidized to iron positive 3, that has configuration argon 18 for S0 3d5. That means, as shown on the screen, with the oxidation of iron positive 2 to iron positive 3, we have reached to the half-filled D sublevel, which is more stable since it is half-filled. While in manganese, that has electronic configuration argon 18 for S2 3d5, and manganese positive 2 has configuration argon 18 3d5, that when oxidized to manganese positive 3 has configuration argon 18 3d4. As shown on the screen, on oxidation of manganese positive 2 to manganese positive 4, we don't have half-filled D sublevel. So manganese positive 2 is more stable as it has half-filled D sublevel. Another give reason in this point, it is difficult to get scandium positive 4 in its compounds. The reason for that, that scandium has configuration argon 18 for S2 3D1. So when scandium is oxidized to scandium positive 4, it will break completely filled energy level. Now, my dear student, we can define the transition element. Transition elements are the element that have partially filled D or F sublevel in their free state or ionic state, not both of them, either this or that. So we have give reason in this point. Zinc, cadmium and mercury are not transition elements. The reason for that, because they have completely filled the sublevel in all their free states, such as zinc has electronic configuration argon 18 for S2 3D10 and its oxidation state positive 2 has configuration argon 18 for S0 3D10, so has completely filled the sublevel in both the atomic state and the ionic state. Another give reason here, my dear student, in this point, coin age metals of group 1b, which are copper, silver and gold, are transition elements. The reason for this, my dear student, because in the free states copper argon 18 for S1 3D10 and ionic state positive 2, that is copper positive 2, has configuration argon 18 for S0 3D9. Or positive 3, the sublevel D will be partially filled either by D9 in positive 2 and in positive 3 oxidation state D will be 8. So it is partially filled in the oxidation state, so it is transition element. Now, my dear students, we are going to discuss the general properties of the various transition series. Now we are going to discuss the first property, which is the atomic mass. It increases with increasing the atomic number, except nickel that has 5 stable isotopes with average mass 58.7 atomic mass unit. Second property is the atomic radius. Here, my dear student, we find that there is a small decrease gradually, while nearly constant from chromium to copper. The reason for that, my dear student, is due to two factors opposite to each other. These are increasing in the positive nuclear charge that increases the attraction force of the electrons, and the opposite factor is the increases of the number of electrons in the 3D sublevel that increases the repulsion force between the electrons. Now, my dear students, we can use this property that the radius is nearly constant, that the elements of the first transition series are used in making different types of alloys. So the reason for making different types of alloys from first transition series is because their atomic radius is nearly constant. My dear student, notice that the ionization energy increases from left to right and the oxidation becomes more difficult as the increase of the positive nuclear charge. Now, my dear students, we are going to discuss the metallic property. These elements are solid metals having metallic luster, good conductor of heat and electricity, and they have high melting and boiling point. And so we have good reason for this point. The reason for that is due to the strong interatomic bonding, which is metallic bond, that involves the electrons of both 4s and the 3d sublevel in their electron cloud. My dear students, we find that the first transition elements have high density, which increases with increasing the atomic number. So we have good reason for this point. The reason for that, because the atomic mass increases while the atomic radius is nearly constant. So when the atomic mass increases with the increasing of atomic number and the atomic radius is nearly constant and the density equal the mass over the volume. So we have reached to the atomic mass that is very high, so the increasing the density. My dear student, the first transition series have variable chemical reactivity, and so we have give reason for this point. The reason for that, the copper has low reactivity and the iron has medium reactivity, the rust when exposed to air, and scandium is having high reactivity. Now, my dear student, we are going to discuss some questions on this episode. The first type of questions, choose the correct answer. In the first transition series, the ion is more stable when the 3D sublevel is half filled, completely filled, empty, all the previous. If you think about it, my dear student, you will find the answer, it will be all the previous. Next point, the maximum value of oxidation state in the elements of the first transition series occurs in vanadium or chromium or iron or manganese. If you think about it, yes, it will be in manganese. Next point, in the same period of the transition element, as the atomic number is increased, its ionization energy decreases, or its diameter increases, or it is difficult to be oxidized, or its density decreases. If you think about it, yes, you will find that it is difficult to be oxidized. Next type of question, give reason for. The abnormal electronic configuration of chromium and copper, because the configuration of chromium argon 18 for S1 3D5, here the 3D sublevel is half filled, which have lower energy and extra stability, while in copper that has configuration argon 18 for S1 3D10, the 3D sublevel is completely filled, which is more stable and less energy. The next point, transition metals show several oxidation states. The reason for that, because their valence electrons in the 4s and 3D sublevels are near to each other in energy, that lose the electrons from them successfully. Next point, all first transition series have oxidation number positive 2, except scandium have oxidation number positive 3 only. The reason for that, because scandium has electronic configuration argon 18 for S2 3D1, when it loses 2 electrons from the 4s sublevel and 1 electron from the 3D sublevel, it gets an empty D sublevel, which is more stable. Next point, the maximum oxidation states for the first transition series increases from scandium to manganese. The reason for that is losing the electron from 4s and the 3D sublevel according to the oxidation state. And next point here, the oxidation states of first transition series decreases from manganese to zinc. The reason for that is due to the increase in the ionization energy as the increase of the positive nuclear charge. Next point, oxidation of iron positive 2 to iron positive 3 is easy, while that of manganese positive 2 to manganese positive 3 is difficult. The reason for that, iron has configuration argon 18 for S2 3D6. So iron positive 2 has configuration argon 18 3D6, that's when oxidized to iron positive 3 has configuration argon 18 3D5, which is more stable since it has half-filled D sublevel, while manganese has configuration argon 18 for S2 3D5, and so when manganese positive 2 is formed, here argon 18 3D5 the configuration that when oxidized into manganese positive 3 has configuration argon 18 3D4, which means that it breaks the half-filled d sublevel. The next point, as shown on the screen, is zinc, cadmium, and mercury are not transition elements. The reason for that, because they have completely filled the sublevel in all their free states and ionic states, where zinc in the atomic state has configuration argon 18 for S2 3D10, while in the oxidation state positive 2 has configuration argon 18 for S0 3D10, so 3D sublevel is completely filled in both cases. Next point, coin edge metals of group 1b, copper, silver, and gold are transition elements. The reason for that, in the free states copper, argon 18 for S1 3D10, and the ionic state positive 2, copper positive 2, argon 18 3D9, and positive 3, the sublevel D, will be partially filled, D9 or D8. Next type of question, my dear student, is to choose the correct answer. The element in which its outer levels have the electronic configuration 5F14, 6D6, 7S2 is from what transition series? Is it first, fourth, second, or inner lanthonide? If you think about it, my dear student, you will find that it is from the fourth transition series. Next point, the element in which its outer energy level have the electronic configuration for F14, 5D2, 6S2 is from what transition series? Is it third, inner actinides, or second, or inner lanthonide? If you think about it, my dear student, you will find that the answer is third transition series. Next point, element which is strong as steel but less dense. Is it scandium or titanium or iron or zinc? If you think about it, yes, it will be titanium. Next point, element which we use in plating metals and leather tanning. Is it scandium or chromium or iron or zinc? If you think about it, yes, it will be chromium. Next point, element which is rarely found in the Earth's crust. Is it cobalt, scandium, iron, or zinc? If you think about it, yes, it will be scandium. Next point, element which we use in TV photography at night. Is it titanium, scandium, iron, zinc? If you think about it, my dear student, it will be scandium. Next point, element which is highly reactive but resists the effect of air. Is it scandium, chromium, iron, or zinc? Yes, the answer is chromium. Next point, element which is used in reinforced concrete and electricity pylons. Is it scandium, or iron, or chromium, or zinc? If you think about it, yes, it will be iron. Next point, element which is catalyst to convert water gas to liquid fuel by Fischer-Tropsch process. Is it scandium, or iron, or chromium, or zinc? Yes, the answer, as shown on the screen, it will be iron. Yes. Next point, the element that can be magnetized and used in manufacture of dry batteries in modern cars. Is it scandium, or cobalt, or chromium, or zinc? Yes, my dear student, the answer is cobalt. Next point, radioactive element which is used in the preservation of food and detecting cracks. Is it scandium, or cobalt, or chromium, or zinc? If you think about it, my dear student, you will find the answer is cobalt. Next point, radioactive element which is used in medicine as diagnosing and treating tumors. Is it scandium, or cobalt, or chromium, or zinc? Yes, the answer, it will be cobalt. Next point, substance which we use in the manufacture of some protection cosmetics. Is it chromium oxide or titanium dioxide or vanadium pentoxide or manganese dioxide? Yes, if you think about it, it will be titanium dioxide. Next point, substance which is used as insecticide and fungicide in purification of drinking water. Is it chromium oxide or copper sulfate or vanadium oxide or manganese dioxide? If you think about it, yes, my dear student, it will be copper sulfate. Next point, substance which is used in the manufacture of paints, rubber and cosmetics. Is it chromium oxide, zinc oxide, or vanadium pentoxide, or manganese dioxide? If you think about it, yes, my dear student, it will be zinc oxide. Next point, element which is used in making Fehling solution that detect glucose sugar. Is it chromium, copper, vanadium, manganese? If you think about it, yes, it will be copper. Next point, substance which is used in the manufacture of illuminating paints and X-ray screens. Is it chromium oxide, zinc sulfide, or vanadium pentoxide, or manganese dioxide? If you think about it, my dear student, it will be zinc sulfide. Next point, substance which is used as oxidizing agent and as antiseptic. Is it chromium oxide or potassium permanganate or vanadium pentoxide or manganese dioxide? If you think about it, my dear students, the answer it will be potassium permanganate. Next point, substance which is a strong oxidizing agent in dry cells. Is it chromium oxide or manganese dioxide or vanadium pentoxide or potassium permanganate? If you think about it, yes, the answer it will be manganese dioxide. Next point, substance which is fungicide can be used as fungicide. Is it copper sulfate or manganese sulfate or vanadium pentoxide or A and B together? Yes, the answer it will be A and B together. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So, till we meet again, my best wishes for you.